Okay, so let's start the session. So this is 2 credit hours, right? So we do not have time for tutorial and practical, but normally what I do, I will have like 1 hour session for the lecture, and then the remaining will do some exercise or some practical for you to understand better. Okay, so this is introduction to machine learning. Okay, so today plan is we will look into the overview of machine learning, why we study this machine learning, and we look also the cost logistic. How do we assess you? What are the plan and so on? And then we go a brief introduction to machine learning. Okay. Okay, why do we learn machine learning? Okay, you are measuring in mathematics and computer graphic, right? So you may have to apply some kind of intelligence in your project, or you may need to look into some of the solution integrated with the AI technique. Okay, so this course is designed to teach student on what are the concept, what are the technologies available out there in relation to machine learning. Okay, but in most cases, we will apply this one in several domains. For example, we look into food security, okay, precision agriculture system, in which we will get all the data from the sensor or from the data acquisition devices. For example, we look into remote sensing through the satellite image. We also look at the weather data through the sensor, or we go to the ground and then take the data. Okay, we also can do soil analysis data using sensor. Okay, we look at the level of moisture, temperature, nutrition content of that particular soil and so on. We also could look at the hyperspectral images that we can capture using drone, or we could take from the satellite image. Okay, so based on this data that we have, we will process them. Okay, so we will store them in the database. So for us to be able to get some knowledge from the data, we need to use machine learning. So machine learning will be applied here. Okay, machine learning. So we can do some yield prediction. We also look at the quality prediction, where we say, okay, this is grade A, grade B, and so on. And also we can look at the rate of growth for your crops and so on. So once we get the capability to predict, then we can implement any intelligent application. So this can be used for decision making later on for food security, uh, in order to enhance the crops production. Okay, so this is in precision agriculture. Okay, if you like to work in hospital or in clinic, so machine learning also can be applied in healthcare, in which we can looking at how do we detect disease, how do we classify disease, how do we predict the type of disease that we have. We also can use medical imaging in classifying the type of disease that we have. For example, we're looking at the brain tumor image. We can decide whether a person can have a brain tumor based on the MRI scan that we have. We also can look at the structure of the protein. So we look at the how do we store the database, the data, and then we can differentiate the structure of the protein. We can look at the smart health record in which we record all the demography of individual person, and then we can do some prediction. Okay, we can personalize medical treatment based on individual health condition. Okay, and this is we can do some disease prediction as well based on external data, internal data that we can combine. Okay, so this is in healthcare. In education, okay, nowadays all of you are using ChatGPT. Uh, now almost all the application use some kind of chat GPT application in order to enhance the learning process. Okay, so you can use chat GPT to speed up your search and also enhance your um, learning process by not having to use Google and then summarize them by your own. Okay, and also we can also use AI to personalize your learning, in which they look at your performance and they will personalize your learning process. So this is similar to this one. Okay, so where they um, creating customized learning content based on your understanding, based on the performance of your test or quiz or assignment. So the thing that you are weak in certain subject, they will give you more exercise. Okay, so this is automatic. Yeah? So we as a lecturer also we can do this, but if we have 300-400 students in our class, so it is a bit difficult for us to monitor individually. Okay, we can also use machine learning to do some machine translation for multilingual courses. Okay, so if you want to teach this course in English, this course is also available in Chinese or in Malay or in French or in Spanish or in other language. So that is machine translation content. Okay. So we also look at the lifelong learning. How do you apply machine learning in real world application and so on. Okay. So these are the three main area. Of course, we can apply machine learning in marketing or in tourism, in other sector. Okay. So for this course, the course learning outcome, we will look into the concept and technique. Okay, so this is the course learning outcome number one. So we are looking at the ability to gain knowledge and understanding. So this one I will use the quiz and also the midterm to assess you. Okay, and we will also do some practical on how to apply the method in solving certain problem. So you will have to do some practical application. And at the same time, also, I will give you some assignment for you to solve individually. So this one, I will use the practical and also the assignment to assess you. Okay. And finally, by the end of the course, you should be able to understand the concept, you apply the technique, and you should be able to evaluate the performance of the model. And this one will be tested in the final exam. final exam. So meaning that by the end of the semester, you should have the knowledge on how to apply the model, and then you should be able to evaluate the performance of the um, machine learning. Okay, so if you look at the topic that you'll cover today, we will cover this, and then we will look into the binary and multi-class classification, regression, neural network. Okay, and we also looking at the classification, and this is the cluster analysis, and then this is where we combine several models to become ensemble model, and the last one is how do we do the machine learning experiment. Okay, so we have a total of 12. Okay, some of the topic you may have to go through on your own. We call it PTG. I guess we have 4 or 5. Okay, but don't worry, we will provide a video for you to guide you. Okay, so this is the content that we will cover in this course, and then this is how we assess you. So assignment 20%, practical, quizzes, midterm, and final exam. So this 40% should be in your hand, meaning that you you have all the time to complete the practical, the assignment, and the quizzes should be straightforward. So you will be taking the quiz online. Okay, so we will set the expired time for you to complete the quiz before the deadline. Okay, so we will have the midterm in week 7 or 8. Okay, and then final exam. Okay, sometimes you might not be able to come to the class or join us online, so you need to provide show course later lah. So this is just formality for me to keep in the record course file. Okay. Or if you have not submitted your assignment or your practical assignment after the due date, we will have 50% deduction from the full mark. So if the full mark is 10, so that means if you are late, meaning over the deadline, maximum you can get is 5. So this is like second chance lah. Okay. So meaning that even if you submit the assignment late after final exam, you only can get 50%. Okay. So please remember that if I go back to here, if you do not submit any of this practical, or if you did not submit any of this assignment, so meaning that you get 0, so the whole grade will be F, even if you pass the passing mark. Okay, if you get 45, for example, 45%, but you did not submit any of the assignment or you did not take any of the quizzes, then you will be getting an F. Okay, so that is just a reminder, because in every semester definitely there will be 1 or 2. Okay, so hopefully this semester we do not have F grade student. Okay, any question? If you okay, can you type number 3?
Prof, sorry to bother. May I ask, What language will we be using any programming language to do machine learning?
Okay. For this course, we will be using the R software. You can download them from the internet. This is open source software. So basically, you will learn some of the statement on how to open a file, how do you do some data analysis. So we will learn that one step by step. It doesn't require any heavy programming unless if you go for Python. Okay, so R software is a very basic one, but you could write a script using R in order to perform some tasks. Okay, but we will do a light one. So just to show you how do we call the model, how do we apply the model to perform some data analysis. So yes, um, later on if you are free, then you need to download the software lah. It's called R software. Okay, so good question, Catherine.
Okay, Prof,
Yeah,
because early on our semester we use R Studio. Is it similar to R software?
yeah. The R come in many versions, so we'll also be using the R Studio. So, so what tasks are you performing when you use the R Studio?
Uh, we do data analytic on the R Studio, so that's why I asked about it
Or
early on semester.
the basic statistics? You mean? What?
No, because uh, our second semester we learn about basic data analytic.
For example,
So yeah,
what kind of
uh, we we just do simple graphs and we do relation between the variables, something like that.
okay, okay. So you
Uh,
are more into exploring and managing and visualizing the data lah, right?
yes, Prof.
Okay, okay. So that's good. You have basic background on how to perform data analysis. So that is normally what we call it basic data science lah. So you know how to import your data and then do some um, tasks in order to get the descriptive statistic. Okay, so that's good. Okay, so for this course, any more question? Any more question? No. Okay. So for this course, this is called machine learning. But before we proceed, we have to look at what is actually machine learning. So machine learning normally always mentioned together with business intelligence, data mining, statistics, knowledge discovery, and AI. But we really need to understand what is machine learning actually. Okay, so how do we define machine learning? So first, we will look into the definition of machine learning and how this machine learning term can be related to other terms like business intelligence, data mining, statistics, and knowledge discovery, AI, and so on. Okay, so basically, the machine learning focus on the development of a program that can assess the data and also use it to learn them. So to learn them meaning that to model them, to extract frequent trend that we have in that particular data. Okay, so basically machine learning is just a program in which you extract and then you do some processing and then you display the output. Okay, but in order for us to program this machine learning, we have to use certain type of what we call it computation. Okay, so in most machine learning, or in all of them, they use the statistics. So statistics is a study of how to collect, organize, analyze, and interpret numerical information from the data. So basically, we are looking at the numerical information that we have from our data. So machine learning applies statistics in order to perform some of the tasks included in the supervised, unsupervised learning that they have. Okay. Um, Here in FKI, we also have data mining. So what is data mining? So basically, this is a process in which we apply machine learning algorithm to extract the knowledge, to learn data available from domain to solve domain-related problem. So data mining is actually a process to mine the data or to extract information from the data using machine learning. Okay, so that's how we relate data mining and machine learning. We apply machine learning to perform the data mining process. Okay. Um, some people also mention about AI. So AI is a scientific study to develop a system or software to mimic human intelligence. For example, speech recognition, reasoning, computer vision, and so on. Okay, so some of these intelligence that include vision, language, and also reasoning. Okay, so all this they we use machine learning. So machine learning is a subset under AI because we say we need to teach the machine on how to model the data. So machine learning is a subset of AI because AI is a big umbrella. It actually the scientific study of how to mimic human intelligence. Okay, and we also have this business intelligence. Business intelligence normally used in finance or in economy or in business. This is a technology-driven process for analyzing data and presenting actionable information to help in decision making. So, business intelligence is actually a concept in which we use technology or intelligent technology to analyze our data for decision making. Okay. So, in order for us to extract the new knowledge, we use machine learning, right? In which in the machine learning we apply statistics to, and this machine learning is used in the data mining. Okay, and the last one will be knowledge knowledge discovery. So knowledge discovery is the science of finding pattern within set of data, and data mining is part of knowledge discovery process. So this is a bigger term that we use in order to say you are doing some research on knowledge discovery that apply data mining. No, data mining is one of the process in knowledge discovery. Okay, let me show you a bigger picture of knowledge discovery. So this is the knowledge discovery process in which we call it the cross-industry standard process for data mining, CRISP, DM. Okay, so data mining is part of the knowledge discovery process, which is this one. Okay, so in any organization, we have to look at the business understanding. We have to look at the business objective. We need to determine the data mining goal, what are they looking at, what they want to do with the data, and so on. Okay, once we get the business objective, then we look at the what data should we collect. Okay, we need to list all the relevant data that we need to collect. How do we export the data? How do we verify the data quality and so on? Okay, so once we that's why for all the final year students who are doing project in relation to machine learning, the most important part is to obtain the data set first. Where do you get the data from, and what is the problem that you want to solve? Okay, so once we get the data set, then we say, okay, how do we select relevant data? How do we filter out all the irrelevant data? So there must be a technique. So, and also if you have missing data, how do you handle missing data? Okay, so this one you will filter data, you will clean the data, you will maybe combine a few column to become one column, one feature, or you may int- integrate, meaning that you will integrate with external data to get more related data to be analyzed together. Okay, so once we prepare the data for modeling, then we can perform the data modeling. So this is sometimes called data mining. So we select the model or we select the machine learning algorithm technique, and we will perform the training and testing, and then we will get some result from this. Okay, so after we fine tune, after we optimize the model, then we can evaluate the result. So if we satisfy with them, then we will deploy them. Otherwise, we have to refer back to here, the business understanding, whether we map the objective to the result correctly or not. Okay, so this is the knowledge um, discovery process. Okay, so like I mentioned just now, your data will be the most important part. How do you collect the data? Where do you get the data from? How do you verify the data? So your data is the most important part. Okay, but now people talk about big data, right? What is big data? So this is the question that we need to look into. We need to define what is big data. So big data can be defined using 5V. Okay, so the 5V stand for, the first one is volume, a huge amount of data, and the second one is variety. So variety refer to the different format. For example, we have text, we have table, we have images, we have audio, and we have images or video. Okay, so there are a variety of format, and also we have value. Okay, some of the data cost you very high because you need to spend a lot of money to get the data. For example, buying new equipment, or you need to spend money to hire specialists to collect the data, or maybe the data only can be collected at certain time frame. So that is the cost of the data value. It refers to the value of the data. Okay, and we also have the velocity. Velocity meaning that the data is always coming to you. So this is coming from sensor. The data always captured by the system. So how do you process them? So this is time series. Okay, and also the it will be huge because it will always be coming. So they're coming from sensor and so on. Okay, and the last one is veracity. Veracity refer to how valid is your data at that particular time. For example, we can make a certain decision based on the exchange rate. But as we all know, exchange rate can be different every day. Okay, so by the time um, we have to make decision making, we have to look at what is the current information that we have. How do we verify? How do we validate the data that we have? Okay, so these are the 5V of big data. So you should be able to define what is big data. Okay, so when we try to combine big data and machine learning, so basically we have the data here, the big data, okay, and we have the machine learning. So the domain model is referring to, remember that we talked about the agriculture, healthcare, education. So this is your domain. Okay, so machine learning is the program that you design and you have all the data. So it could be big data. So by combining all this, then we can develop certain apps in order to produce intelligent features. So for example, like we can perform some predictive analytics, we can do intelligent search, we can have recommendation engine to recommend certain product based on review or based on your purchase history and so on. Okay, so that's how all of these are interconnected. So you will have to look into this. Okay, machine learning model that we have, machine learning algorithm, and there are some overlapping also. Machine learning is under AI, so like I mentioned just now, AI is a systematic study on how to mimic human intelligence that include reasoning, speech that include natural language processing and planning and so on, and some more here like computer vision and so on. Okay, so when we look at the type of intelligence here, then we can divide the type of machine learning that we have. So this is the type of machine learning that we have. So we have supervised, unsupervised, reinforced learning, and deep learning. So this is depends on the application. You will learn more about this: supervised, unsupervised, reinforced learning, and deep learning. Okay, so basically, deep learning is one of the subset in machine learning because they are using neural network but more complex. So that's why they call it deep learning. So what is supervised? What is unsupervised learning? We will look into that one later on. So this is another map that show you, okay, data science looking into analyzing the data for a very basic function. Machine learning is under AI, and then deep learning is under machine learning. Okay, and the big data will have overlap on all these three: machine learning, deep learning, and data science, in which we will apply machine learning to process big data. We also use deep learning method in order to process big data, and also we have some descriptive statistic tool that we can use to process the big data. Okay, so these are the 9 top application of machine learning: identification of spam, recommending products based on your purchase history and your hobby, customer segmentation for marketing. Okay, we segment the customer based on their demography or based on the purchase history. We also look at the image video recognition. So this is for biometric authentication, behavior analysis. Okay, we also have fraudulent transaction in order to detect fraud transaction. We also looking at the supply demand forecasting in order to um, do some intervention in order to ensure that supply always meet the demand. Okay. We also have virtual personal assistant like your timetabling, meeting, and so on. We also do some sentiment analysis in which we look at the news and then we try to extract the sentiment whether it is positive or negative or neutral. Okay. And also we have customer service automation in which if you have any question, then the AI bot will help you in any of your query. Okay, so these are the 9 top application of machine learning. So basically they are in our daily life. Okay, so they are very important. Okay, now we go into type of machine learning. So it depends on the task that we are using. For example, supervised learning, we can use that one for house price prediction. Okay, and also we can use for medical imaging. So this is more on classification and regression. Okay, um, for the unsupervised, we can use this one to group the customer or to perform customer segmentation based on demography information, or we can perform market basket analysis in which we want to know what item always bought together in the market. So this is normally used for business. So they call it unsupervised because we use clustering or grouping, or we find some relation of between the item that we have. This is more into supervised because they perform classification because they have label. Okay, this one have label, this one no label. Okay. Semi-supervised learning, they mix the supervised and unsupervised in which we have a small amount of label data only. So this one can be used for text classification, or we can use this one to for land finding on GPS data. So this is we want to do some decision making in which area we want to land. Okay. And the last one is reinforced learning. Okay, reinforced learning is a bit advanced in which, okay, for example, today is March, right? So we have January, February, and March. Okay, so every month we perform the modeling, and when we perform the modeling in February, we apply the knowledge that we have done before. So this is what we call reinforced learning. We have a window of time frame in which we apply knowledge that is learned before. So in March, we will use the knowledge that we learned from February. So this is normally used in optimized marketing because we are looking at the previous history, driverless car because we are looking at what are the sometimes we call it case by case. So what happen if we have this type of situation? So based on what you have studied before, this what you should do next, and so on. Okay. But in this course, we since this is a basic one, so we will mostly learn about supervised learning and unsupervised learning. And of course, this one also will have many methods. But this will be your foundation for reinforced learning. Okay. So so when we talk about supervised and unsupervised, like I mentioned just now, we have classification, regression for the supervised. And then for the unsupervised, we have clustering and also anomaly detection. So this is more into detecting outlier. So this is coming from the clustering as well. Okay, and the third one is reinforced machine learning. The learning has a constant feedback and the algorithm learn based on the environment. So learning has constant feedback. So meaning that they're getting the feedback from the previous learning process. Okay, so we will look into these four, basically these three lah. Okay, but if have time, I will cover this one. This one is very interesting also because most of you will be working in business or marketing, so machine learning is applied also in marketing using this method. Okay. Okay, if we look at the supervised learning, okay, supervised learning, like for example, we have all the data that we have, okay, and we have target variable. Target variable meaning that we have um, the label. Okay, for example, we have class 1 or class 2 and so on. So we have label. So we train the model. Okay, we train the model. Then we say for class 1, these are the characteristic. For class 2, these are the characteristic. Okay, so once we train them, then we have a new data here. Then based on the characteristic of the data, we say, okay, this data belong to class 1 or class 2. So this is what we call the label. Okay, so they call it supervised because we have the label. So we learn based on the label that we have. Okay, if we compare with unsupervised, okay, that is the next stage. This is the still the supervised because we have the label positive and negative. So we should be able to draw the line to separate the two label, positive and negative. So this one, we say if the income is over theta 1 and the saving is over theta 2, then they are low risk. Okay. Else we have the high risk customer. Okay. So some of the application like pattern recognition, uh, classifying different handwriting style, um, classifying illness, biometric authentication, face recognition, outlier, novelty detection, and so on. Okay, so this is the robot that we visit last time in Japan. In Japan Advanced Institute of Science and Technology. So this robot is designed to assist all people in the healthcare sector. So they will be helping the old people by looking at their needs and so on. But when I try to talk to this robot, they cannot understand me because they only understand Japanese language. Okay. Okay. These are the application of supervised learning to for prediction of future cases. So this is regression. We can also extract rule from the data in order to perform classification. And the rule is simpler than the data it explain, meaning that based on the rule, we can perform the classification. Okay, the rule is something like this. So this is what we call the rule. Okay, so your model should be able to come up with this rule when you present the data for this one. Like you have saving and income, you have the label, then the model will produce this. Okay. Um, outlier detection. This one we can use clustering. Okay, you will learn clustering as well. Okay, And just now is the classification. This is regression predicting the numerical value. So if you have all your data in a numerical value, so if you want to model them, like to do forecasting, so this is what we call regression. So what we want to do is we want to draw a line that will minimize the residual value. Residual value refer to the differences between the predicted value and the actual value. So this is your actual value. This is your actual value. This is the predicted value because we draw a line. Okay. In other cases where you have more complex trend, we use polynomial regression, or we can use deep learning in order to model a more complex trend. Okay, for this is called linear regression because we assume that there is a straight line that we can draw to model the data. Okay, so this is polynomial regression. Okay, so that is supervised learning. So supervised learning, we have classification and also regression. We will look into these two. Okay. Um, Today, what we want to do is we just want to have an overview what is supervised, what is unsupervised learning. So for unsupervised learning, this one do not require any label. So what happens is that we given the data here without any label. So we use this clustering to perform some grouping or some clustering, or we could use the unsupervised learning to find some relation in the data. Okay. So once we train the model, then we have new input. So we can put them in the right cluster, okay, or in the right group. Okay. So that is what we call unsupervised machine learning. So that involves clustering. So this is the clustering. Okay. So if we look at our curriculum, it consists of all these three. Okay, regression, classification, and clustering. So for that, having to know that we will learn more about this week by week. Okay, so when we want to train the model, basically we have to split the data into training and testing. So you will go through this process many times again. So basically we have the training phase, and then we have the testing phase, and also deployment phase. Okay, during the training phase, we get the input, and then we have the label here. Then we will train our data here. So once we have trained the data here, then we use the testing data, and then we will compare them with the actual and also the predicted value. So this is how we compute the accuracy. Okay. And once we are satisfied with the model that we train, then we can deploy them for real world application. So this is the model that we have here. Then you have new input every day. Then you can perform some prediction. Okay. So always remember in the supervised learning, we need to have training and testing model. So we will look into this. We will show step by step on how you perform the training and also the testing for classification. Okay. Let me. Okay. For us to evaluate the performance, so we will be using. Um, let's say. Let's go back. So um, for us to evaluate the performance, we will look into the what we call it, the true false Now, we, we call it true positive and true negative. Okay. So, for example, if your actual value is true and then your predicted value is also true, so this is true positive. Okay. But if your actual is false and then your predicted value is true, that is false positive. Okay, because you said this is true, so but the actual one is false, so this is false positive lah. So if the val- the value is true, but you say this is false, so this is false negative. Okay, because we assume they are negative, but the actual value is true, so this is false negative. So if this is false, the actual value is false, then if we predict them as false, so this is true negative. Okay, so we will use this value in order to form the accuracy. Okay, so your accuracy will depend on the true positive and true negative here. So for the true positive rate, we are looking at how many of them that we actually uh, predict them correctly and divide by the total positive and false negative. So this is the whole population. And the true negative rate, so this one referring to the other class. Okay, so we call it sensitivity for the positive class and specificity for the negative class. Okay, so we will go over this one in order to evaluate, assess the model. So we will go do some exercise. Okay, so this is the accuracy, the total positive, the true positive plus the true negative, meaning that you need to get all of these correctly classified, divide the positive and negative label. So this is the accuracy. Okay, so the precision will look at how many of them that you correctly classify as positive, and the recall uh, refer to, no, this is the percentage of true positive. This is the percentage of the portion of the true positive against the false negative. So a bit confusing now because you do not have any example what is true positive and false positive and so on, but we will look into some of the example. Um, the, the best example is here. So if the actual value is true and you predict them as true, then this is true positive. But on the other way, if the actual value is true, but you predict as false, so this is false negative. Okay. Similar to this, if the actual value is false and you predict them as um, false, then that is true negative. So what we want to do is we want to increase this one, this two, and we want to reduce this because this is the error that we have. So that's why your accuracy is depends on TP and TN. Okay, your accuracy depends on true positive and true negative here. Okay. Okay. There is another way on how you measure the accuracy is by looking at the F score. The F score is making use of the precision and recall that we have previously here. So they are defined based on the true positive and also the true Precision and recall is defined based on the portion of the true positive here. But the divider is different. This is more on the false positive. This is more on the false negative. Okay. Okay, I think you have studied correlation. So correlation, looking at how um, the degree of correlation is being formed between all the data that we have. Okay, so for example, if we have two variable, okay, so if two variable are highly correlated, that means any changes in x, it will also reflect the value to y. Okay, so we can say this is large positive correlation because very close to the line. This one weak correlation because although the line is going here, but the value that we have is not consistent close to the line. Okay, so this is negative. Okay. We also use this mean square error to measure the differences between the line, the actual value that we get from the line and also the line from the value outside here. Okay, so the mean square error is we want to find the differences between the predicted value from the actual value, and then we square them in order to erase the negative value and then take the average. Okay, we sum up them. So you will learn this thing also later on. This is used to measure the quality of your model. Okay, so that depends on the true positive and also the false positive. Later on, you will study this one also. This is just to give you an overview. So this is to um, measure the or to compare the performance of one model to the other. Okay. So if someone asks you, how do you compare the performance of model? So we can say we can use the receiver operating characteristic in order to compare the two models that we have. So what happened here is that what is true positive? True positive means that if the actual value is true and you predict them as true, right? So this is true positive. So what you want to have is you want to increase the percentage of true positive here. Okay, what is false positive? So false positive is that um, the value is true, but you predict them as false. Okay, so you want to reduce this one, false positive. So that means if you are here and then you're going up, so that means you have better performance over here, right? You want to reduce this, you want to maximize this area. So you have to go from the end here going here. So maximize area under the curve. So the bigger area we have, the better it is. But this one is the average. Okay. So that's how we measure the performance of the model based on the true positive rate and also based on the false positive rate. So the idea is we want to maximize area under the curve. Okay, so we will learn this one. How do we plot this curve later on? Okay, next one is the unsupervised learning, clustering, no label, and so on. So they're used for customer segmentation, uh, image compression. This is for the color quantization. This is bioinformatics, learning the motif, meaning that learning any kind of relation between the feature that we have. Okay. We also have the market basket analysis, in which what is the probability of um, having no what is the probability of buying a chip given a beer? So this is 0.7%. Okay, so we use probability in order to look at the market basket analysis. So this one is, so we have two. One is clustering, one is the market basket analysis. Okay, so if we look at the general trend of the machine learning, we have classic learning. So classic learning, we have supervised learning. So it could be divided into classification and also regression. So we will learn like linear regression, we will learn k-nearest neighbor, logistic regression, naive bias, decision tree, and for the unsupervised, we will learn k-means for the clustering. Okay, and for the this one, we could learn this one. We'll see. We will fit into the schedule. Okay, so this is the classical learning. We also have the artificial neural network. So we will have the multi-layer perceptron. Okay, and we may have time to study the LSTM. Okay, and also we have this ensemble. So ensemble learning is designed to improve the performance of the learning by combining a few of them. So we will learn other boosts. Okay, and these are the section that we will leave out from this session, more advanced lah. We have another mapping. This is from Microsoft. So you start here. So we have a big area. So we have if you want to predict, if you want to predict, then you go here. If you just want to group them, then you do the clustering here. So for the prediction, if you are try to predict value, then you go for regression. But if you are looking for categorical value, then we have multi-class or binary class. So this is multi-class referring to more than two classes. Two class means, or binary may refer to only two classes. Okay, in this one also we can say that, okay, we have classification, we have clustering, we have regression. Okay, so by now you have the idea that we need to learn all these things: regression, classification, and clustering. Those three. And this one also looking at variant of each of the model that we have. For example, for regression, we have so many variant. Okay, for the deep learning also, we have so many variant of deep learning. Ensemble also, we have decision tree also, Bayesian, instant-based clustering also. So all the one that I circle, you will learn about this. Okay, let me skip this one. Okay, this is the sample of project that we have done. Just to give you an overview, what kind of application that we do when we apply machine learning. This one, we looking at the deep learning approach to estimate the weight based on the image. So we took the image of the cattle, then we weight the weight of the cattle. So different image will be associated with different weight. Okay, so we learn how to estimate the weight based on the image, side image, and top image. Okay, Because for them to weight the kettle, you need to make them queue and then go through this weighting scale system, and then they will be able to capture the weight just by bringing the kettle to the line in order to weight the weight of the kettle. So very time consuming. So we in this project we proposed a deep learning approach to automatically estimate the weight of the kettle. Okay. We also have this one. This is to predict the health of the beef cattle. So the health will be will be modeled based on the weight and also the movement of the cattle. So we capture the movement of the cattle and also the weight of the cattle in time series. Then we can predict the health of the beef cattle. Okay, this one is we looking at the carbon stock. So what happened is that we capture the image of the forest and we classify the type of forest they have. Then based on that, we can estimate the carbon stock because different forests provide different level of carbon stock. So this one based on the image that we capture from the satellite. Okay, this is looking into the health of the paddy rice. So we take hyperspectral images and then we will look into the health of the soil. So in the image, they show you different color for different level of health of the soil. So we can focus more on the land which is less productive. Okay. This is for the face recognition. This is me and my student. So his name is also Rainer. So now he graduated last year, no, last year, and he joined us in the faculty last year also. So this one we work with Cybersecurity Malaysia. Okay, so enough with that one. So just to mention some of the challenges is that we still have lack of awareness for top management to change direction because they still don't not convinced with the benefit of using AI. So um, of course, young people like you all will easily be convinced, but most of the top management now are all veteran. Okay. At the same time, also we have island of system where your system are developed independently. There is no integration, so very hard to capture the data for data analysis. We Nobody want to share the data. Lack of support or no open data because to capture the data is very costly. The value of the data is maybe confidential or not available for the public. Poor data capturing because we simply capture the data without looking into the business objective, and there is no storage, proper storage for us to access. And last one is lack of local expertise in data science. So that's why you have to take this course to enhance your knowledge in applying machine learning language. Okay. Okay. So that's the end of the session for today. So if you look at the photo here, this is I'm trying to communicate with this robot. The robot name is Pepper. Okay. Um, but the robot only understand Japanese language, so you need to switch mode lah to English. Okay. And let me